last semester actually. So this is the sample one. We're going to go over it. We're going to talk about. You already know these answers, even if you don't know these answers yet. There might be a couple things we don't know about C++. We'll talk about. So this is the stuff on Blackboard. So let's take a look at that first question there and the second question. Go ahead and read the two questions before you read the answers. And before we talk about the answers, let's talk about what the questions are. You can read the answers too, but there's a difference between what those questions are asking. What is the difference? That's the important part. Can everybody read that in the back? Look good? Okay. So in the difference between question 1 and 2, besides the trivial difference between printf and scanf, they're both formatted scanners and printers. What's the big difference between 1 and 2? What's the question? What's the difference in question?
One asks about the programmer, and one asks about the designers who do it.
Right. So every language has a designer. Every language has a developer. If we look at C, the designers of C are K&R. I don't remember. Richie and Kenneth or Richie and Nuth or something like that. I don't remember the K for now, for example. I spaced it. But K&R were the designers of C, or they were the primary designers of C. And so as the primary designers, they made a lot of design decisions when they were making C. What are the decisions that they made, and why did they make those decisions? And that's what 2 is asking. They're not asking about why you do this as a programmer, right? Whereas number 1 is, why do you do this as a programmer? So for example, number 1, as a programmer, why must you specify a format string? Out of those 4, which is the best answer? Because there might be possibly multiple correct answers, but there's one best answer there.
B? Question mark?
B, question mark? So you say, we have B, and what was the other one?
C.
C, there are no strings in C. Okay. That's kind of true, but not really true. We have char star, which is a string in C. That's just, we don't have the string data type. D, C doesn't know about how to check for data. Does anyone think that A is the correct answer? Good. One adventurous soul, because A is the correct answer in this case. Because that now this is so this is essentially a trick question. And when I gave this midterm, nobody got this right. Well, I think like 3 people got it right or something like that. Because it is a trick question. Why is this a trick question? Or what's the trick about these questions?
Answers in 2?
So in 2 and 1, they're different. They're slightly different questions. Again, the question is very slightly different.
Because, I don't know, as a programmer, we don't really write the methods, we just give them, and we just use them how to...
Yeah. If printf didn't take a format string when the designer chose to make printf take something else, would we use a format string? No, we don't have a choice as a programmer. So number 1, yeah, it might be true when the developer was making it, but as a programmer that's using C, I don't have a choice in this matter. I can't choose that. Right? I can't choose this, and I can't choose this. None of these things are things that I have access to as a programmer. They're just facts of life that I deal with. And A is the only answer in this case. And this is the difference between a person who uses a language and a person who develops a language. Right? Kind of weird way to think about that. So number 2, what's the correct answer for number 2?
B? Question mark?
B, question mark? Yeah. So B is the correct answer for number 2, right? Why is A not correct? Because they wrote it.
They're not limited by it.
Yeah. This is true. That is true. Scanf is written such that it requires a format string as input. If this question said, as a programmer, why do we do this? A is true. But as the developer of the language, the fact that you did something is true isn't why you did that. Why did you make that design choice of the language? And so one of the things about this class is the difference between using a language and developing a language, or why languages work. And so one of the things is with this midterm, we go from a practical language usage course into a more theoretical language development course. And so we have to be able to do both. When you're in a job and you get hired, there's a lot of things that you're going to be expected to do. You're going to be expected to learn languages rapidly. And so this first part of this course is a lot of me talking about how we can learn new languages, the differences between some languages, and then a lot of, here's homework, go fucking do it. Right? Go learn some shit. And a lot of it's like, oh my god, like, dude, he didn't teach us how to do this, I didn't know these things, I didn't know. Well, guess what? Welcome to real life. Like, that's the way this is going to work.
Professor Google.
Huh?
Professor Google.
Professor Google. When you get your real job, they're going to go out there, they're going to be like, hey, I need you to go implement this in Sandforce. And you'll be like, what the fuck is Sandforce? All right. We're going to figure that out. Or you're like, oh, hey, we have this, we use, let's suppose you get hired by WordPress, as an example. They're like, oh, yeah, we use PHP, MySQL, and PHP 5, MySQL 5, and some other NoSQL database that we haven't told you about yet. And you're like, neat. You're like, can you go implement this database connection? You're like, uh-huh, I'll get back to you in a week, kind of deal. And you have to learn those technologies on your own. The same way that I've kind of forced you to learn these technologies, this C and this bash stuff on your own kind of to start with. But at the same time, those things aren't necessarily useful for you in learning or understanding why languages or how languages are built themselves. An example of this is, let's think about, there's contractors and there's engineers. What's the difference between a contractor and an engineer?
A contractor organizes and engineer builds.
Okay. I would say that's not necessarily, that actually wouldn't be true. You might be able to convince me of the answer, but I'm not sold on it right away.
A contractor builds stuff to a certain specification where the engineer develops, I don't know, like new and innovates.
So the engineer defines the specification. The engineer makes the specification, the contractor builds to that specification. So if you're building a house, as an example, I don't know if you guys are familiar with this, but if you're building a house and the contractor comes up to you and or you're watching your house being built, because most of us aren't going to build our own houses, and the contractor takes this really 16 penny nail, drives a 16 penny nail, and you're like, dude, that's a really big nail. Why'd you use that? The contractor's going to be like, because the engineer told me to. And if you go back and you're like, hey, engineer, why did you choose to use that 16 penny nail? And the engineer's going to be like, oh, because the shear load on this wall causes it such that you have to have at least 800 foot-pounds of torque against this nail. Otherwise, this nail is going to shear off and the wall will fall down. Two very different answers. The result is ultimately the same. You want a house that stands up. And the contractor might be able to tell you the difference between a 16 penny and an 8 penny nail. And ultimately, the contractor that can tell you the difference will be able to build a better house because they'll be able to know more things. But the engineer might not be able to build you a house, whereas a regular contractor might not be able to tell you why. You want to be able to try to do both of those things. Computer science and programming is kind of in that same kind of flux. You have a programmer who is a builder. They build things. They make applications. And then you also have a computer scientist who makes the reasons why you build things in certain ways. You have to be able to try to marry those two of those together. So the first half of this course is, how do you be a programmer? The second half of this course is going to be, how do you be a computer scientist? Right. Both of those things are going to be important. And that's what that's the difference between these two questions here. All right, let's move on. Number 3. When organizing the actions of several programs, it is often useful to write programs using shell scripting, bash, which is a shell scripting language. It's one of several. For example, we could also use C shell or K shell or tickle shell or any other shell scripting language. But bash is the one we were talking about, so it's a shell scripting. Why is that true?
You can take outputs from one program and put them into the next program.
You can also do that in C, but it is not nearly as easy. When you take the 570 course, you'll do this in C, and you'll be like, okay, I get it, but it's not nearly as easy.
Because the point of scripting languages is to run other
Yeah, that's probably the better answer. Part of that is true, but the point of the scripting language is to run other programs, which is what results in your answer. What's the purpose of a pointer? Two of the above.
Two of the above. One of them.
Any two, pick two.
C.
D.
Alright, so C is the one we talked about in class. Absolutely, right? We talked about being able to access different parts of the memory at the same time. We also talked about the fact that pointers are equivalent to what? An array, right? What is an array?
Data structure.
It's a data structure that does what?
Holds data.
Allows you to access many elements of data through a single variable name. Right? Array of index 0, array of index 1, array of index 2, array of index 3, etc., etc. And so that's what an array is. In the sense of array and pointers are essentially the same thing. A is true. C is also true because that's the one we explicitly did. So at least D is true. And since there is no E everything, we could probably say that D might not be true. One of the things is B is true. We can access data on the stack through a pointer. But it's not the only purpose. The purpose of a pointer is not to allow access to the data on the stack. That's the purpose of a variable. The variable name, not the pointer. We can, but it's not the purpose of it. Yeah, if it said the heap, that might be more true. That's actually more true if it said heap. Number 5. Where do local variables have their memory placed on by the compiler? Typically. In most languages.
Stack. C.
On the stack is the most common answer.
1 out of
You can
5.
be super technical and be like, yeah, on the CPU in the registers, and it optimizes, and it stopped. It's on the stack. We can do lots of optimizations so that we don't access memory. We can do lots of other things, but in general, it's put on the stack. Modern languages, most modern languages actually go away from this, but they still maintain the stack heap concept. They say, oh yeah, function variables go on the stack. The fact that the stack is actually the heap doesn't matter. For example, C#, Python, Lua, and what was the other one? JavaScript. Those 4 languages do not have a difference between a stack and heap. It is all the heap. But when you're talking about it conceptually, they conceptually separate the stack and the heap, and the function things go on the stack, and everything, and the dynamic goes on the heap. In practice, in reality, everything just goes on the heap. What is the result of the above? Assume you got the correct answer for number 5.
D. D.
I'm going to read all the answers first. The stack requires more space than programs. No, that's not true. CPU performance is dictated by the number of variables you define. That's not true either. C, programming languages require the programmer to understand their implementation. Is that true?
Yeah.
So do you have to understand how scanf works?
No.
No. So programmers require the programmer to understand their implementation. Is that true? No, it's false, right? So A is false, B is false, C is false, therefore
D is true.
D is true. Yeah. This is how we get scope. When we talk about scope being limited, the reason why scope is limited is because functions put their data on the stack. And then if we in 237, if you haven't taken 237 yet, I'm sorry about this. But as a subroutine grows, the stack goes up, and different subroutines have access to the stack at different points. That's the definition of scope. That's where the definition of scope comes from. 7. How do large-scale projects like operating systems are developed in C without object-oriented programming? A is probably the best answer. A is probably the best answer. One of the things is, if we said that, if we treated a kernel or we treated an operating system as a monolithic thing, as an example, we would be in the multi-million lines of code. And most of these things, for example, the cat program. What does cat do? Concatenates stuff together or displays the text of a file to a screen. What does echo do?
Prints on the screen.
Prints its command line arguments to the screen, right? It prints to the screen. Those are very simple programs, and those are part of the operating system. Now, if I considered cat and echo not to be independent programs, but instead considered to be part of, say, the kernel, and I say now you have to go find that code inside the millions of lines that exist inside the kernel, this problem becomes much more difficult. When we do this compartmentalization, it allows us to be much more proficient, or much more prolific in terms of amount of code. So the same concept allows us to do an object-oriented programming. When we want to be able to do a large project, we're able to compartmentalize concepts into classes. And so the same class has all the similar concepts, and that's how we do the same kind of thing. Like, for example, we could have the cut class, which implements the cut functionality for an operating system, as opposed to having the cut program. But it's essentially the same thing. We still want to do that breakdown. So the second section is short answer. Why do we define classes in object-oriented programming languages? Try to do this in 7 words. So we can use it. Oh, that's 5 words. It's pretty good. So in order to reuse code is an okay answer, but it would not be correct in this case here. If we talk about why do we have functions, that would be a better answer for functions, but not for classes.
To create custom data types.
So that is true. That is what classes do for us, but that's not necessarily why we do that.
So you have
You're-
polymorphism, inheritance.
That's so we do get those things, but that's not. But we gain those things when we use classes, but that still doesn't say why we use classes in object-oriented programming. Yes, we're on the right track. Because breaking down problems into smaller parts, that's probably the best answer so far. And it's true. It's pretty good. Very good. In the short, kind of so non-specific that the answer might be there, right?
To change the behavior of similar
You're on the right track now, but you're being a little too specific.
To further customize that apps?
Closer. So we're all kind of like grouped into this thing here. So I'm going to tell you kind of what I'm looking for in this kind of answer. All of these things are true about object-oriented programming. But really why we define classes in object-oriented programming is to break the concepts in a program into things that we understand as humans. And so, like, for example, we group all of the apple parts in the apple class. And then we can talk about apples as being fruits. So the reason why we use classes and the reason why we use object-oriented programming is to turn difficult programming tasks into human conceptual objects. Human conceptual things. You don't want to use the word objects in there. So really it's about making programming easier for us, which is why you're right, but you have to say why it's easier for us.
So, in other words, if we put biological terms, it'll be like putting a bunch of organs together to create living species.
It's easier to talk about as a dog, as opposed to saying, oh yeah, that's a brain and that's a heart and those are some 4 feet, and,
Yeah.
right?
Yeah.
And so it allows us to compartmentalize the way humans do. That's really the whole part of object-oriented programming. Everything else he said was true though, so good job. Why do we use malloc and new? So new, we haven't quite covered new well enough. We'll talk about it a little more today or on Monday. Tuesday, sorry.
To allocate memory? Malloc?
To allocate memory is excellent. It's true. Yeah, so if you said on the heap, that's the big part. We want to be able to allocate memory on the heap. There's another word that we might want to use in there. Starts with a D. Dynamically allocate memory on the heap. That would probably be the best answer. Why is it important for a programmer to understand scope? Started to raise your hand and then you put your hand. You're like, no.
Because if the variable goes out of scope, it can break your program if you try to use it.
That's true. And so if you were going to shorten that, what would you say?
Variables are only accessible using everything
That's true. Yes, so that's pretty good. If you don't understand scope, you will write broken code. That's kind of the gist of what you said, right? It's difficult to be able to be what level of specificity do we want to be here? And so the free response questions here, I'd grade relatively generously. So for like that first one when we were talking about and we're like you're shooting things all over the place, I would have given you probably everybody full credit for all those answers that you gave me. For this one here, even if you didn't say dynamically allocate for number 2, I probably would have still given you full credit if you just said allocate memory. Understand scope, if you had said something similar to what you said originally, I probably would have given you full credit. It's so that you can effectively use your variable names and not in a way that allows you to produce easily understandable code, easily understandable programs.
So, for that question, is the main part effectively use variable?
So effectively use variables, yeah. It's about the effectively using the variables without breaking your shit. That's really what it's all about. If you don't understand scope, you can't use variables effectively. You end up things with like x1, x2, x3, x4, and then you don't know if a variable is accessible. You don't know where that memory is anymore. You don't know if it's on the stack. You don't know if it's on the heap. You don't know which function it can access. Why do I have a pointer? Why do we need pointers to be able to share between different functions? Because the variables don't translate scope. That's the whole point of pointers, so that they can both point to the same piece of data across different scopes. One of the ports, anyways. Number 4, why are shell scripting languages usually not appropriate for large-scale applications? One reason is good enough. There's many. It's very hard to do math. That's a good answer. Particularly, you want to do Excel? Yeah, you're kind of fucked.
Even data too.
Possibly, I might take that answer. It depends on how many people said it. If a lot of people said it, I won't ding a bunch of people.
They generally only operate in strings.
Yeah, that would be probably a better answer than a limited number. That's good. It's the same thing as it's hard to work with integers. What else? I know one glaring one for myself is the syntax is atrocious. Right? Trying to oh man, my spacing is wrong. Those things. It's difficult to. I have too many tabs over here and not enough over here. Or I forgot a semicolon when I didn't need a semicolon. Do you even use semicolons in Bash? Can you? Sometimes you have to. Did you know that? Like, oh my god, right? Oh, so those kind of things. Those are all valid reasons. There's many more of them. If you came up with like, if you said variable names, you can't put a space after a variable name. I probably would have. Yeah, okay, good enough reason. Number 5. Yeah.
Was one of them that the variables are global? Did you mention that something like that?
You could totally say that as well. Variables are global. They're not exactly global, but they're more or less global. It's difficult to have classes. If you didn't say it's not object-oriented, that's another reason. It's difficult. How do you write functions and subroutines is more difficult. Those things aren't intuitive. And how many people wrote a function in Bash? Nobody has, right? How many people have even looked at writing functions? Maybe 1 or 2? Yeah. So all of those reasons are valid. In C and C++, why is it not appropriate to return a reference to a local variable?
Because they're located on the stack and the stack is cleared as soon as it's executed.
It's not necessarily that the stack is cleared, but that we can say it's cleared because really that stack is no longer used and is now considered garbage. And so we say cleared, we should actually say it's gone to garbage. In some languages like Java and Python and Lua, the stack is actually zeroed. In other languages like C and C++, it is not zeroed, but it's just garbage. But good enough answer. If you said it's cleared, I would have given you credit.
So you will get garbage in that case,
You
right?
get garbage. And you might get the right answer, but the right answer is a lucky right answer, not the correct right answer. So fill in the blanks. If you've taken classes with me before, you might be familiar with these.
Lovely.
Write the boxes. Provided if it's an error is produced, write the word error. If garbage is produced, write the word garbage. Half credit for using garbage and error if you switch the two of them. So we'll talk about the C++ stuff here in a second. But for example here, what would be produced on the screen? This is stuff that is printed to standard out. So you'll notice that what is the following code print to standard out? How many people the answer is 3? Good. How many people think the answer is 3.1459? Good. 3.14. Yeah. Alright, so people who didn't raise their hands, what did you think was printed?
I'm still reading.
Yeah.
Oh, we're still reading? I'm sorry. I'm sorry. What are we doing? Alright, so If you're still reading, you haven't gotten to that point yet. I'm sorry, I went a little fast there. I got through the problem like, oh, everyone else is done, right? No, sorry about that. So the things to look at here is this fprintf is being printed to a file that we've opened. Does that go out to standard out? No, so we can eliminate this fprintf. Does the file modify what's being printed on standard out? No, so we're going to ignore that part too. That f right there inside that printf, right? Do I care about this x anymore? No, I don't even care what that's doing anymore. So I don't even. So essentially, what I've done here is I've narrowed down the things that I have to know about and things that I have to understand. So when I go, standard out, that's the printf. Don't care, don't care, don't care. F. That f is 3.1459. 0.2 means I'm going to do 3, and then I'm going to have how many decimal places?
2.
2 decimal places. So I'm going to get 3.14. Now I'm going to get 3.14 or 3.15.
4.
1.4?
Yeah.
The answer is it depends. Hi.
Hi, I'm sorry. I teach in this class and I forgot my scarf earlier today. Do you see one on the chair?
Yes. That's yours?
Thank you. Sorry. Sorry to interrupt.
You're okay. You're all good. Okay, so 3.14 and 3.15, I would accept either one of those answers because the answer is it's C implementation specific. Yes?
Why does the actual value of it is
Because 3.1459 is technically a double, and the compiler yells at you when you try to store a double inside of a float. And so that's actual implementation specific as well. It depends. On OS 10, this is 3.15, I believe. On Linux, most Linuxes it's 3.14. It depends on whether or not it rounds 5 up or down, and whether or not it takes into consideration that 9. Either one of them are acceptable, as long as you understand that concept. For 2 and 3, assume you have the following item class and it's fully implemented in C. So when I say it's fully implemented in C, you should assume that all of these functions are implemented. They're not implemented here, but you should assume that they're implemented and they're implemented correctly. So they do what they say they should be doing here. What does the following print to the screen? So this part down here, you might not quite understand how this code works, but we'll talk about what it's doing there to understand this question. And this syntax, this arrow syntax, might be new to you as well. We'll talk about that as well. So what does cout do? Prints to the screen. That says we're going to stuff whatever's in here into the cout, and then we're going to stuff whatever's in there into the cout. Okay. In this case here, when I say item jack 10 here, so the string jack, what I've done is I've declared a variable named jack of type item. The constructor is called with the jack as the first name and 10 is the quantity. And so for here, we call this constructor, which would have set its member variables quantity and names correctly. When I say Joe arrow get name, I'm using a specific way of accessing this variable Joe. That's Jack. Sorry, we'll get to Joe. So item Joe is a pointer to a Joe item. It is not a Joe item itself. So if you want to think about this as pictures, did I lose a bunch of markers somewhere? It's possible. That's unfortunate. So we have an item. We have a big item object. This item object is the Jack, correct? And then we have a Joe. And Joe is not an item. Joe is simply a pointer to an item. And so when we do the ampersand Jack here, the ampersand Jack says give me the address of Jack, which is this big memory location here. Joe is a pointer that points at Jack. When we use the arrow says let's follow this pointer and access the item inside of it, or the object inside of it. So example here, we're going to follow the Joe pointer and access that object there. We're going to access the name. What's the name of this Joe pointer?
Jack.
Jack. So this part is going to put Jack onto the screen. Okay. The second part of this is going to say Jack arrow get quantity. The arrow operator, which is this dash right caret, the arrow operator means what again?
Follow the pointer.
Follow the pointer. So we're going to come over here. And we're going to treat the first 4 bytes of this as a pointer and go off into garbage. Access its quantity, which is garbage. This is actually an error here. This part's an error. We're gonna look at a couple of explicit examples of that today. No, it's supposed to be a dot. So this should be a dot, but this is not mistyped on the test. Because the correct answer for this is error.
Error.
Error is the correct answer for this. If you wrote garbage for this, you would have gotten half credit.
Jack.
No. The compiler wouldn't even compile it. The compiler would be like, no. So this is one of the things is when we go to C++ as opposed to C, the C++ compiler goes, Jack is an item, not an item pointer. That goes on pointers. That is not a pointer. Not letting you do this. Yes? How would I make that right? So the answer to make this right, I believe I can answer. Yes, I can. That is correct. So we talked about using the dot operator when we were using the structs in C. That was because we were using the pointer as well. We could also use the arrow operator in C instead of the index. Anyway, all right. We'll talk about that. We'll do some explicit examples of these two. Yes? Correct. Correct. If you get an error, the whole thing is an error. All right. Let's move on to the next one. So item star stuff equals new item. So item star stuff, this stuff is a pointer to a set of items, right? How many items did I declare? 10 of them. So stuff is actually a pointer to an array of items, not a single item. It's actually an array of items here. When I say item test stuff 30, test becomes a variable. So it's the same kind of deal here where we say, instead of Jack here, we have now test, correct? That's the name of it, test. Here, and now we have stuff. Stuff is not pointing at test. Stuff is pointing at an array of 10 items through there. Printed to the screen, remember? This is the part that we're looking for. OF stream file, file.open, C out. Does this file pointer access matter? No, because we're looking for printed to the standard out, printed to the screen. And so we're only looking at the C out here. Test.getName. The answer would be stuff. So the answers here would be stuff. This other part with the OF file stream, the file.open, the file left arrow, and all that other stuff, that's just to confuse the fuck out of you. Did it work? Sometimes it did, sometimes it doesn't. So what you're looking for is, what is this question asking? How much do you have to know? Even if you don't know what this does, because this actually technically works, this would return garbage here. We would put garbage into the file. This is not an error because that is a valid place. Stuff plus 4, so stuff plus 0 is this one, stuff plus 1, stuff plus 2, stuff plus 3, stuff plus 4 would be this guy down here. Have I put anything inside of here? No, garbage is inside of there. And so this guy's name would be garbage, and so I'd put garbage into the file. I don't know what I'd actually put there, but it would be garbage. But do I print that to the screen? No. Does it cause an error? No. So I print to the screen stuff. You serious about this shit? That's the look he's giving me right now.
Yeah, I'm lost.
Okay.
I don't know what happened there.
What the hell is going on over here? Alright, so let's do some pointer stuff. Let's do some pointer things before we look at the rest of the text. Alright. Maybe that's what I thought. Okay. So in C++, if I have a class like item, let's suppose we have that item class we're using before, and I say item like this, I give it a variable name, foo, like so. If I try to end it like this, that's an error, technically. Because what this is saying is I want an foo item. This is of type foo. So I want to be able to say, here is my item, its name is foo. The problem with this is I have not constructed it. When you create objects, you have to be able to construct them with the constructor call, like so. And so the constructor call is what allows us to create that object. In Java, when we would do something similar in Java, I would have to do something like this. Item bar equals new item. Like so. Correct? When I say new, where am I allocating memory?
The heap.
On the heap. That tells you bar is what kind of variable? It's a pointer. In Java, Java doesn't explicitly tell you about pointers because you cannot do this in Java. You cannot create objects that are not pointers. Everything in Java is a pointer, with the exception of the primitive data types. So when I do this in Java, I don't have to do the star here in Java because it already is a pointer. In C++, I can create items on the stack and I can create items on the heap. I can do both. I have more flexibility in where I put my memory. If I want to put them on the stack, I declare them like so. And that's now declared on the stack. But if I want to declare them on the heap, I have to declare them with the new. But this is not a pointer, this is the item here. Whereas this is a pointer to the item, so I have to declare it with the star in C++. So both of these declarations are correct in C++, whereas only one of them is correct in Java. Java simplifies this by removing that process. By removing the ability to put things on objects on the stack, Java has simplified the concept of pointers to the fact that there are no pointers. So there's no difference between pointers and non-pointers. That's the reason why in Java, when I want to access an item, so for example, I want to access, let's use bar in Java. When I want to access bar, I say bar.getName. Because bar is always going to be a pointer in Java. In C, this is not true. Not everything is a pointer in C. And so we have two different access specifiers. We have the arrow, which is access the member of a pointer. And we also have the dot, which is access the member of the object. This is the reason why Java maintained the dot operator as opposed to the arrow operator. So Java only has one method because it only has one place you can allocate memory. C has two methods because you have two places to allocate memory. Bash has none of them because Bash doesn't allocate memory for objects. It doesn't have object-oriented program. In this case here, in C++, bar is of what type?
It's a
It's
pointer.
an item pointer. That means I should use which one of these accessors? The arrow, because it's accessing the pointer one, so this should be a pointer. When I go to use foo, which one of these should I use? The dot, because I'm accessing the object directly.
Do you have the dot operator in C?
You have the dot. We had the dot operator in C. We used it when we used
But
the
we don't have
structs.
objects though, right?
Correct, but we had structs. So when we say what is the difference between C and C++, C++ is object-oriented programming and C does not. Correct? C has structs. C++ has classes. When we have classes, what do we gain over C++ or over C? What is the power of classes over structs? inheritance, polymorphism, and so functions we can put in either one of them. Functions or data. We can put a function pointing in the struct, or we can put a function inside of a class. Both of them we can do that. One more thing, one really big thing.
You don't have to worry about the memory. I mean, like freeing it.
Oh, so that's we have to worry about freeing for both of them. That's something else. You're right.
Does it compile something to
No. Good guess though.
Public, private.
Access specifiers. Everything in C is public. There's nothing other than public in C. In C++, you get public, private, protected. Now I can say, don't touch my privates. That's what the C++ allows you to do. C doesn't give you that possibility. So C, everybody can just access everything. They're like, go for it. You're like, eh. So in C++, when we want to declare objects or declare classes, we have the two different methods. We have the method that declares it on the stack and the method that declares it on the heap. C++ also has the ability to declare not just a single thing, but an array of things. So for example, I can also do item cat. Oh man, hard brackets are terrible. Cat, like so. Cat is now an array of 10 items. Where is this array declared?
Stack.
On the stack, correct. I can also declare an array of 10 items like so. Where is that declared?
The heap.
On the heap. Cat is of what type?
Item.
So is cat a single item? Cat is an item array, right?
Oh, they're cats.
All right, so dog is of what type? A pointer. Pointers and arrays are what? The same thing. So cat is a pointer. Dog is also a pointer. They just point to different locations in memory. Cat points to a location on the stack. Dog points to a location in the heap. If I wanted to access them, this is where it gets. This is the step that gets the. God damn it! This is the reason why Java did away with this. Let's suppose I want to access the first elements of cat's name. To do that, I would say cat of 0, right? C++. This would also be true for C, though. Cat of 0, dot or arrow here.
Cat of 0.
So what is cat of 0? So if I have, so it's not a pointer to the first. It is the first. So if I have an array,
That's what she meant.
right? I mean, this is, what the fuck is going on? Cat is a pointer to there, right? Cat is a pointer to the beginning of the array. When I say cat of 0, I am saying the first element of cat. What is this thing right here? It's an object, so I use the dot operator. Right? All right, so let's write this a different way. Because cat of 0, the way we wrote that, can be written a different way. We can also write cat of 0 to be the access of cat, let's say cat plus 0 here, dot get name. Because cat plus 0 means take the pointer of cat, add nothing to it, stay in this location here. Star means access that location, which is this location here. Dot means that's that object of that get name. We can write it a third way.
Oh way. Oh.
This third way is cat plus 0. What is cat plus 0? A pointer. Do I use the asterisk, the star, to access that memory location? I do not. What does the arrow say? Member of the pointer. Yes?
Is there any specific like situations where you don't use one or the other, or are they just all interchangeable?
So they are equivalent. However, I would never recommend that you do these because these two you're like just simply because you can doesn't mean you should. This is the answer. This is what you should do. It doesn't mean that that this isn't a valid thing here, and that's where in the question up there, that's where this part comes from, because this is still a valid thing there. The way I made that question easier is I didn't make that one of the printouts, so you didn't have to know how exactly that worked. I'm going to do one more thing just to demonstrate what all the equivalents would be. So for example, if I wanted to access the fourth element, I would say cat of 3 here to access the fourth element, correct?
Mm-hmm.
I would also say cat plus 3 and cat plus 3 here. I don't have to worry about the number of bytes that I have to be modifying by. If you remember in 237, when you do arrays, you have a pointer to the beginning of the array. You have to know how wide that array is and multiply by it so you can go down a number of bytes. This is not the number of bytes. This does all the addition and multiplication for you so it has the correct number so that it accesses the correct place. Questions about that? Look of horror. We're not even here. Well, okay, I'm already checked out. We're gone. So, this is another one of those instances where C gives you C++ and C gives you more power than maybe you actually want, or more ability. So let's take a look at that again real quick. So we look at this guy here. We see that stuff plus 4. Stuff is that pointer. We add 4 items to it. We access its memory, right? And then we say .get name, so that's a legal access. However, it doesn't matter because that's going to a file and I don't care about that. Test is an item, and the dot allows you to use the get name without worrying about the arrow. The one above it, you can see that Joe is the pointer, and Joe uses the arrow. Jack, because it was originally not Jack dot, it was originally Jack arrow. Jack is not a pointer, and I use the arrow, which causes the error. Yes?
So on the third question, it says item test.
Mm-hmm.
So it creates an item and then just puts stuff and 30 in it
Correct.
with the name test.
Correct.
So that's it. No array, nothing else, just
No, right,
one
just
thing.
one element.
But
one
that
element.
goes on the stack though, right?
Huh? This goes on the stack, correct.
Okay.
The stuff variable goes where?
On the heap.
So the items go on the heap. The stuff variable goes on the stack. Because it's a pointer to things on the heap. So let's take this a step back. Where do all variables go?
Stack.
On the stack. Stuff is a
Pointer.
pointers, and it's a variable, so it goes
Zero.
on
On
the
the
stack. Right? Test is a variable. It goes on the stack. These things go on the heap. When we're looking at these guys over here, cat is a variable that is an array where all of its memory is allocated on the stack. Dog is a pointer allocated on the stack with a bunch of items allocated on the heap.
Do they go on the heap because of that star?
Because of the new.
New.
Of the new?
New allocates things on the heap. Where does malloc and new allocate things? On the heap. What's the purpose of malloc and new? To allocate things on the heap.
So all variables go
on the stack.
on the stack.
Yeah.
That's
So
why
this,
it didn't make sense.
we see how we get in all these parts together that don't necessarily. Okay, let's go look at these again. Where do local variables have their memory placed by compilers? On the stack, right?
Mm-hmm.
What is the purpose, or why do we use malloc and new? To allocate things on the heap.
Let's click it in.
Okay, man.
Okay. Yes.
So Java non-primitives go in the heap then?
Say that one more time.
Java non-primitives go in the heap.
Yes.
The primitives go in the heap, but they go in the stack.
Primitives go on the stack. Java's weird because it does actually have a stack heap dichotomy, and it does do that. C or C sharp, everything is a there are no primitives. Everything is an object. Everything goes on the heap. And it's interesting. In C sharp, you can do some. C sharp is an interesting language. I'm going to show you something real quick here. The same way we could say in C sharp, the item stuff equals new item of 10. The same way we could do that. We could also say, for example, equals new item, a single item. The same way we did before, say stuff dot. In C sharp, you can also do something like this. You can say, hey, 3 dot 2 double. So 3 is a value, is an integer value, right? But it's also an object that you can call 2 double on. So literally everything in C sharp is an object. Java says everything's an object except for primitives, and then has a bunch of special cases for primitives. C sharp goes, fuck it, everything's an object.
It's hard to access that later.
Yeah. It's... All right. So number 4. This is usually the hardest question on the test for most people. The question here is, can you follow what's happening? I'm not actually going to go over this today in class. I believe the output is something like 10 garbage 1 or something like that. But yeah,
Is there going to be a version of this?
this is on the blackboard.
It's on Blackboard. Yep, but there's no answers.
The answers are not there. I'll post the answers on Tuesday next week. The solution to this takes a long time. What I would do is if you that first time when you were like, oh, how do I go through code? That's what this question is asking you: is how fast are you able to read code, understand what it's doing, look at it? Nothing is wrong with this code, and when you look at the one on the test, nothing will be wrong with the one on the test. What it's asking you to do is it's asking you to. I'm not trying to trick you with syntax. I'm asking you to be able to follow code and be able to do code logic in your head. If there is an error, I'll fix it for this question. I know, I can try. I can try. I'll try my hardest. The last section of the test is to pick a language and then do this. So print the 27th Fibonacci number. If you chose Bash, I'd be like, it doesn't do integers. What are you doing? If you chose C, that's great. If you chose C++, that'd also be fine. But print the 27th Fibonacci number. If you know how to do Fibonacci numerically and you just wrote the answer out, I wasn't giving people credit for that because that defeats the purpose of the question. One person tried to do it last semester. They knew the formula for Fibonacci as opposed to how to write the algorithm, so they just wrote the answer down. Like in Bash, they said echo with the answer. I'm like, no, that's okay.
What if you don't know the formula?
Well, so then you calculate it. So there's both an algebraic formula and there's an algorithm for it. And if you don't know the algorithm, I'll give you the algorithm for Fibonacci. I provided it on the test. How many people do not know the algorithm for Fibonacci? How many people have learned it from me but have not remembered it? There we go. Okay. So Fibonacci's are very straightforward. Relatively straightforward algorithm. It's used a lot because it has most of the basic stuff. However you want. It doesn't matter. It doesn't matter if it works. So for example, if you try to do this, the 27 Fibonacci number recursively in C, you probably can't, is the answer. I don't think, maybe 27 is too big. I don't know, it's pretty big though. But Fibonacci is essentially, you have, you start with two numbers, I start with 1 and 1 every time. So the first number is Fibonacci, yeah. Wait, what am I doing? Yeah. Fibonacci, you start with two numbers. So the first number is 1, the second number is 1. The third number is the previous two numbers added together. So it goes 1, 1, 2. You take the previous two numbers and you add them together. So 2 plus 1 is
3,
3 plus 2 is
5,
5 plus 3 is
8.
8. And so what you do is you have the third, fourth, fifth, sixth. What's the sixth Fibonacci number?
8.
8. So when I say 27th, you have to calculate out a long way. Yes?
I know you're talking about the use for maybe, but doesn't it
So there's two definitions. One of them starts at 0, one of them starts at 1. I define it to start at 1, 1. If you happen to implement it 0, 1, I'd still give you full credit. But the definition for them depends upon what you're trying to do. Either one, both of them are correct. So I define it to start at 1, 1, not 0, 1. Some people define it to start at 0, 1. They're both correct. So any questions about Fibonacci, how you do that? So one of the questions is, how do you implement this in an algorithm? There's two relatively simple solutions. One is recursive, one is iterative. I'll give you both, actually. I'll give you the recursive solution. So the simplest C recursive solution would be the following. You'd have your pound include stdio. Then you have your int main. You'd say printf %d new line fib of 27, like so. And then you'd have your int fib int